Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, today we are going to look at a couple of different shapes. We have worked with cubes, we have worked with prisms, and we've worked with cylinders. And now we're going to look and see about the volume of cones and pyramids and see how the cones and pyramids are related to the cylinders and pyramids. No, I'm sorry, and prisms. So first of all, a cone is similar to a cylinder in that it's got a circular base, but it's different in that it only has one circular base. And it comes to a point at the top. So while the cylinder had like that rectangular lateral face that works its way around, it looks triangular. If you were to see the net of a cone laid out, it wouldn't quite look like a triangle, but it's kind of going in that direction. So cones and pyramids, they have one thing in common. They are a couple things in common. They come to a single point at the top, and they have a single base at the bottom. And once again, the base is what names the pyramid. So this particular pyramid would be either a square pyramid or a rectangular pyramid, depending on the dimensions of those sides. But once again, only one base, and then it has triangular lateral faces that all converge to a single point at the top. Okay, so there are formulas for finding surface area of cones and pyramids. Thankfully, we are not going to go there in 8th grade. We did the surface area for cylinders and for prisms, but it gets a lot more complicated with cones and pyramids, and that's something that probably is going to be an IM1 or IM2, I would imagine 9th grade math. So let's move forward with this. So cones and pyramids are three-dimensional objects that have only one base and that come to a point opposite their base. A cone has a circular base, and a pyramid has a base that's a polygon, and lateral faces that are triangles. So once again, it could be a triangle base, it can be a square or rectangle base, it can be a pentagon base, it can be any polygon for its base, and then that polygon base would give you the name of the pyramid. So today you will be investigating how to use what you know about cylinders and prisms to find the volume of a cone and pyramid. Questions to keep in mind are, what is the shape of the base, and how does the shape compare to a cylinder or a prism? All right, why is that coming up? Okay, so how much would it cost? So you have a choice of purchasing a small or a large serving of popcorn at the movies. A small popcorn costs $1.50. So that would be this guy right there. And a large popcorn is going to cost $3.50. So both containers have the same height and they have the same bases with the same circular area. So based on their prices, discuss with your team which container of popcorn you think is the better deal. Once again, we are not with our teams, so just think about that. And I guess what we need to try and figure out is how much popcorn are you getting in there? How much are you getting in here? It doesn't tell us how many ounces or how many cubic centimeters or whatever unit of volume we could work with here of popcorn you're getting in each one. So it's hard to find a unit rate to really make this decision. But one thing I do want to stress to you is that this cone does have the same circular base area, and it has the exact same height as the cylinder. So with that in mind, I'm going to show you an experiment so we can figure out how to find the volume of the cone. Now let's start off with what we already know. We already know that to find the volume of a cylinder or any prism, the volume is going to be equal to the area of the base times the height of that cylinder. And the base area in this particular case is a circle. So we're going to take pi times the radius squared, multiply it times the height, and that would give you the volume. But since I don't know what the height is, and I don't know what the radius is, they didn't give us any of these numbers, we really can't solve anything as it relates to the volume of this cylinder, okay? What I'm going to do now is what I used to do in class is I used to pull out some manipulatives, you know, some clear plastic cones and cylinders and pyramids and prisms. And luckily, I was able to stop by the classroom and film a video yesterday with my son, Ben. So what we're going to do right now is we're going to figure out how to find the formula for the volume of a cone. Okay, so I'm going to pause this video, and then when we come back, we will be doing the demonstration for you.
All right, and joining me for this experiment is my son, Ben. Say hi, Ben.
Hi.
Okay, so what we're going to do is we're going to look at the relationship between the volume of a cylinder and the volume of a cone that has the exact same base area and the exact same height. So just to prove it, Ben, can you verify that the height of this cone is exactly the same as the height? Why don't you go ahead and put it in and see if the tip of it doesn't rest, and hold it up for the camera so they can all see.
Okay, so it is exactly the same height.
Exactly the same height. Does it look like it has the same base area?
Yeah.
Yes, same base area. All right, we're going to do the same thing. Can you verify with the pyramid and the cube?
Yes, this is still, oh, they have the same height.
Same height, same base area. All right, so if you were to predict, Ben, how many of these can I fit into here? What would you predict? What would you think? Come a little closer this way so we're in the camera so they can all see. There we go. That's good. Okay.
I would think it would be about 2/3.
You think it's about 2/3 just by eyeballing it? Okay, and hopefully at home you are making your prediction as well. Now, what I've done for the cylinder is I put these little marks in here where when we fill it up with water, when it goes to there, it's 1/3 of the way up, 2/3 of the way up, and all the way up. So Ben, you're thinking that when I fill this cone up and I pour it into the cylinder, that it'll reach that second mark. Is that what you're thinking?
Around there.
Around there. Okay, so it could actually be 1/2, could be 3/4, but I'm going to tell you right now, I put the marks in this location for a reason, not so it'll not be on one of these marks. So 1/3 or 2/3 would be the obvious guess if you had no idea. So let's do this. Let's pour some water into here, and I don't want to fill it up too high so it'll spill. So
I'll just keep it down.
yeah, you just move those guys out of the way and protect the computer so it doesn't get all wet. That should be, a little more. A little more. Ooh. Okay, so will you hold the cylinder? And I will pour the cone, the contents of the cone, the water, into the cylinder. And can you tell our audience how high up the water went?
It got to the 1/3 mark.
The 1/3 mark. Okay, so the volume of this cone is 1/3 the volume of that cylinder, given that they have the same height and the same base area. Let's see if it works with pyramids and prisms as well. So I'm going to just pour this up so it's almost to the top, not quite spilling. This one does not have markings, but what does it look like, Ben?
Yeah, 1/3.
Looks like 1/3. Okay, so write this in your notes. The volume of any pyramid, the volume of any cone, it doesn't matter what the base of the pyramid is. It can be a triangular pyramid, it can be a rectangular, an octagonal pyramid, any of them. If they have the same base area and the same height, the pyramid or the cone will have exactly 1/3 the volume of its respective prism or cylinder. Thank you, sir. Good job. Appreciate you helping everyone out with that and helping me out.
All right, well, that was fun. So what we discovered is this. We discovered that if you were to fill this full of popcorn, this cone, and then dump that popcorn into this cylinder, that's the 1/3 mark, this is the 2/3 mark, that popcorn would fill up 1/3 of this cylinder. And since our formula for finding the volume of a cylinder is to take the base area times the height, and we know that this fills up 1/3 of that, 1/3 of this cylinder, 1/3 of this volume is equal to this cone. So our formula for finding the volume of a cone is 1/3 times base area times the height. It's as simple as that. So with that in mind, we can now use a strategy to figure out which one of these popcorns would be the better value. If I take 1/3 of $3.50, how much is that? Let's figure that out. $3.50 times 1/3 is the same as $3.50 divided by 3, right? 1/3 means you're breaking it up into 3 equal parts, and you're just going to take one of those. So this would be 3 divided by 3 is 1, and then we bring down the 5. 3 goes into 5 one time, and that's a 2, that's a 0. So what's that going to be, about 16? That's going to be 0.6 repeated. So if these two were equally priced, then if this one was $3.50, then 1/3 of that would be $1, and let's just round it up to 17 cents. If we stuck with the cost of the cone being $1.50, then this should be 3 times that, which should be $4.50. However, this is costing us $1.50, and this is costing us $3.50. So which one is the better deal? I would say, for sure, go with the cylinder. That's going to be the better deal. This is overpriced. It should only be $1.17 if we're basing it on the cylinder's pricing of $3.50 for each one of these. Or we're getting a great bargain here. Instead of paying $4.50, which would be 3 of those, we're only paying $3.50. So I say go with the big popcorn. You're getting a better value. This kind of problem 33 sort of describes what we were just doing. So here's another situation. Based on the relationship you found, the fair price for the popcorn, if the cone costs, we already did that. The fair price would be $4.50 because it would be 3 times that. All right, this is going to be a fast lesson. This is good. All right, so same idea here applies as we saw from the video with pyramids. This particular triangular pyramid has the exact same base area and the exact same height as this rectangular prism. So that means that for this particular prism, we're going to take volume is equal to base area times the height. It just so happens that the base area is a rectangle. So it's base times height again. Different heights here, but we're okay with that. The pyramid with the same base area and the same height is going to have a volume that is 1/3 times whatever that base area times the height is. Okay, so take 3 of those, and it's equal to that. Take 1/3 of that, and it should be equal to this. Well, what's 1/3 of $5.50? That would be 3. That would be 8. And that would be 3, probably 3 repeated, right? So if we're basing our pricing off of this larger popcorn, a fair price for this would be $1.83. If we're basing the price from this and you triple it, a fair price would be $7.50. So once again, getting the bigger popcorn in this particular situation is actually a better value because you're getting 3 times the amount of popcorn for just a little bit more than 2 times the price, right? You double that, you get $5. Well, this is $5.50. So you think, okay, maybe that is the way it should be because you're buying more, you're buying in bulk, you should get a better price for buying more. So yeah, I agree with that. But anyway, same idea. All pyramids and cones that have the same base area and the same height as their respective prisms and cylinders will be 1/3 the volume of those prisms or cylinders. So yeah, I already did that with the video. Let's just move on. Go ahead and pause this video. What I'd like for you to do is take these dimensions and act like these are the dimensions of a cylinder. And actually, let me go ahead and do something here so you can see what we're going at there. Let's see. Oh, is that going to work like that? Does that look like it's about the same? Yeah, pretty good. So this was a cylinder that's going up to the top. It's touching in the center. Nope, I don't want to use that. Stop it. Let's do this. Okay, that's pretty good. All right, so there's the cylinder. So what's the height of this cylinder? It's not the 10 inches. The 10 inches is actually what we would call the slant height of the pyramid. And if we needed to find the surface area of this pyramid, or I'm sorry, of this cone, you would want to use that slant height. This particular 10-inch height is not needed for volume of either the cone or the cylinder. This is the height that we need. The height of the cylinder is the distance between the top and the bottom, perpendicular to both of those bases. So it looks like the height is 8 inches and the radius is 6 inches. Okay, so let's figure out what the volume of the cylinder would be, and then we will take 1/3 of that. So 1/3 of the base area times the height. Let's start with the base area, which is going to be pi times the radius squared. So that becomes 36 times pi. Then multiplied again times 8. And once we've done all of that, we are going to divide by 3. Okay, I'm going to pause the video. You go ahead and pause and see if you can come up with the volume of the cylinder first of all. That's what we're getting right here. And then we take 1/3 of it to get the volume of the cone. All right, let's see how you did. So if the radius is 6 inches, we're going to take pi r squared. So we're going to take pi times 6 squared, which is 36 times pi, which I rounded off. It was like 113.09 something that went on. I rounded it to 113.1. And then the height of this cylinder and cone is 8 inches. So I multiply 113.1 times 8 to give us 904.8. That would be the total volume of the entire cylinder if we were working with a cylinder with these dimensions. But we're not. We're working with the cone. And the cone is 1/3 the volume of the cylinder. So we're going to divide that by 3. Multiplying times 1/3 or dividing by 3 is the same thing. And you should have gotten a volume of 301.6 cubic inches. And that's it. So just remember, this is the formula. To find the volume of any cone or prism, use the volume formula for cones and for prisms and cylinders. Did I say that right? Let me back this up. To find the volume of any cone or pyramid, I felt like I said prism there. Any pyramid or cone, you take 1/3 whatever the volume is of the respective cylinder or prism that has the same base area and the same height. And then just use your calculators from there and use your pi button if you're dealing with cones and cylinders. If you're dealing with prisms, then you just use your area models to find those base areas and use your calculator to help you along the way. All right, that was less than 10 minutes. That was a good fast lesson. Oh wait, hold on. Still have like a 3-minute video in between there, don't we? All right, so it took you a little bit of time, but not too bad. All right, take care. Good luck on your homework.
Hey, feeling good, like I should.